Nature does not create perfect angles. At least, it should not. But the Hubble Space Telescope has just found something that breaks that rule. Inside the faint glow of an interstellar object called 3I Atlas, Hubble detected three narrow jets of material. These jets are not random. They form a perfect equilateral triangle. Each one is separated by exactly 120 degrees. This level of symmetry is extremely rare in nature. The probability of it happening by chance is estimated at only 0.2%. That is about one chance in 500. We were looking for a normal comet. Instead, we found geometry that looks intentional. If this is not an extreme coincidence, then it may be a signal, not a message in words, but a message written in math. For months, this object was assumed to be just another silent traveler passing through our solar system, a piece of ice and dust drifting between the stars. But as more data arrived, that simple explanation began to fall apart. This is not just a strange comet. This is the mystery of 3I Atlas. When we observe deep space, we are always looking through interference. Dust, light, and noise hide the details. To see 3I Atlas clearly, astronomers used advanced image processing on data from the Hubble Space Telescope. At first, the object looked unremarkable, just a blurry white cloud. This cloud is called the coma. It forms when sunlight heats frozen material and releases gas and dust. But scientists removed this outer layer using specialized filters. These filters isolate motion and rotation, allowing hidden structures to appear. What they revealed was unexpected. Instead of chaotic outgassing, there were three thin jets, clean, stable, evenly spaced. They did not flicker randomly. They remained consistent as the object rotated. This behavior is unusual. Typical comets produce uneven jets that change constantly. They tumble, they wobble, they behave unpredictably. 3I Atlas does not. It appears balanced. It appears controlled. At this point, scientists were no longer just studying ice and gas. They were studying structure. And structure changes everything. Symmetry on this scale is uncommon in nature. You see symmetry in snowflakes and crystals. You do not usually see it in objects kilometers wide moving through space. But in engineering, symmetry has a purpose. It creates stability. It prevents wobble. It distributes force evenly. Three evenly spaced jets form a perfect triangular balance. This is the same geometry used in spacecraft stabilization systems. Some scientists argue that this could still be natural. They suggest the object might be a contact binary, several pieces fused together long ago, with gas escaping from weak points. In theory, that could explain organized jets, but the numbers make this explanation difficult. For three separate vents to activate at the same intensity, at the same latitude, and remain evenly spaced over time is extremely unlikely. That is where the 0.2% probability comes from. Harvard astronomer Avi Loeb does not claim this is artificial, but he asks an important question. Why is it so balanced? If this is just a rock, then it is one of the most mathematically precise rocks ever observed.
The story is not finished. On March 16, 2026, 3I Atlas will pass close to Jupiter. This is a critical moment. Jupiter has immense gravity. It has torn comets apart before. It exposes weaknesses. It reveals structure. NASA plans to observe this encounter using the Juno spacecraft. This will be our best chance to see how 3I Atlas reacts under extreme gravitational stress. There is a clear contrast in this object. A long, chaotic dust tail stretches far behind it. That looks natural. That looks like a comet. But near the core, the three precise jets remain: calm, balanced, controlled. If this object is fragile, Jupiter will destroy it. But if the jets remain stable, even under that stress, then we may be witnessing something more than survival. We may be witnessing control. 3I Atlas could be a rare natural anomaly, or it could be something that challenges our assumptions about what moves between the stars. Either way, it reminds us of a simple truth. The universe is quiet, but it is not simple. And our understanding of that silence is still incomplete. We are waiting for the data, and until it arrives, we keep watching the darkness.